Okay, so now let's look at how the soil moisture budget works in some real world examples. Okay, so let's head back over to the PowerPoint. Okay, so remember we've got precipitation, the input. So that's the actual transpiration plus the surplus plus or minus it, which is a plus or minus change in soil moisture. When the demand potential exceeds the actual, then we get water deficits. If the actual exceeds what we would normally expect, then we have a water surplus. And anything, if you increase agriculture, for example, you're going to affect the water budget. If you urbanize more, if you have more homes that use more water, that's going to affect water budgets as well. Okay, so here's the annual precipitation in the United States. So we just kind of talked about this eastern part of the United States, southeast and east coast. Remember, Gulf of Mexico has very, very warm water that flows up here as the Gulf Stream, carrying that heat with it. So we get lots of evaporation and condensations, and that comes back down as precipitation. Over here in the Pacific Northwest, remember it's colder water, but it's still warmer than the air. So we still get heat release. That condenses. The westerly winds push it up over the mountains, so we get orographic lifting and great amounts of precipitation up here in the Seattle area, Portland, up here in the west coast of Canada, around Vancouver, for example. And over here in the southern U.S., where we are, and in the southwest, Arizona and New Mexico, for example, because the conditions there, the Rockies come out through here, Sierra's down through here, traps that heat in there, and conditions are very, very dry. So notice, very much less rain here, more rain over here. Now here's the amount of annual potential evapotranspiration. So as you would expect, where we get lots of rain, it's going to be higher. But notice it's very, very high up here. It's because we get the potential, we get very, very little rain, and so most of it evaporates. So it's going to be very high. Same thing here. We get a lot of rain, and not all of it, but a lot of it evaporates, and so we get more rain up and down the coast. So just because this looks high, it's because they get less rain, but it all evaporates. And you can see it again, if you have these prolonged drought conditions, like we've had in California, you can get these devastating wildfires because there's no moisture to keep the trees and the ground growth from staying green and moist. Now here's an easy way to do this. This is Berkeley, California, up around the San Francisco area. So in California, we'll look at this next week or the coming weeks. We're in a Mediterranean climate. That means dry, hot summers and cool, moist winters. So most of our precipitation is going to come in winter months, just like it has recently. And then we get less. So here's the amount of precipitation, this blue line. So notice it's much higher in the winter, and as we get into the summer months, it dramatically decreases, almost zero. And as we hit back into the winter, it goes back up again. Here's the potential evaporation. Okay, so this is what we would normally figure on. Then here's the actual. So wherever this is up here, where the amount of precipitation exceeds this, we get a surplus. Where the amount of precipitation is less, we get a deficit. But here, notice it pretty much evens out. We get lots of moisture, enough moisture in the winter months, don't get any in the summer, but the surplus we gain in the winter pretty much equals the deficit that we have in the summer. That's for Berkeley. Now, the book and so forth will have another one. I think it has Phoenix, for example, where we have big deficits just because there is no rain. So they have to get their water elsewhere. And when you check out that video, moving water across California, one of the things that we do is move water, especially from the Colorado River. Now, okay, so we'll stop here and then cover streams in part 4, okay?